All right, I've kind of been dreading doing this homework. It's going to be a lot of work. We'll see if I can get this all in one video or not. Or I should say in one session. I'm doing 8.4 trigonometric identities. There's lots of problems here. All right, I guess I have to start. So number 9 is our first problem. Number 9, it says, which of these is not an identity? So I'm going to just give you the one that is not, and we'll take a look at why it's not. All the others are. Okay, this one is not an identity, and that is because you just need to know it. Tangent of theta by definition is sine over cosine. So this is obviously the reciprocal. So this, if this said cotangent, we'd be in business, but it says tangent, so this is not an identity. All the others are. Let's look at number 11. So number 11 through 19, the ones I'm going to do, are just getting us ready for the things we're going to need later. So it says to take tangent theta times cosecant theta, and they say to rewrite this in terms of sine and cosine. So we want to get rid of tangent and cosecant, just have sines and cosines here. So I'm going to rewrite tangent of theta as sine theta over cosine theta. That's the definition of tangent. I'm going to rewrite cosecant theta as 1 over sine theta. That's the definition of cosecant. And because this is multiplication, I can just cancel these out. And this is going to be 1 over cosine theta. Now 1 over cosine theta is secant theta, but they ask us to write our answer in terms of sine and cosine, so I'm just going to leave it like that. All right, number 13. It says to take this expression, cosine theta over 1 minus sine theta, and multiply it times 1 plus sine theta over 1 plus sine theta. So what they're trying to get you to see here is that if you were given this to start, that you could multiply it by 1. And this is a very special 1. Something really good is about to happen. Notice I'm taking the denominator and I'm taking its conjugate. So instead of doing a minus between them, I'm doing a plus. And when I multiply this out, some good stuff's going to happen. So first, along the top, these two terms, this is a single term, I just distribute that through. And I get cosine theta plus, I'll do it right this way, sine theta, cosine theta. That's what would happen if I multiply across the top. On the bottom, they both have two terms, so I have to FOIL. So I have to do 1 times 1, which is 1. And then I have to do 1 times sine theta, which is sine theta. And then negative sine theta times 1, which is negative sine theta. And notice these two are opposite in sign, so they're going to cancel. But my last term, I have a positive times a negative, which means I have a negative, and sine times sine is sine squared. So I'm going to write 1 minus sine squared theta, like that. Like I said before, these signs cancel, and so what you're left with is cosine theta plus sine theta, cosine theta times cosine theta, all over 1 minus sine squared theta. Now 1 minus sine squared theta is a Pythagorean identity. We have sine squared theta plus cosine squared theta equals 1. And so if I move this to the other side, do minus sine squared theta on both sides, it'll be gone here. And that means that this is just cosine squared theta. So I can rewrite this as cosine theta 1 plus sine theta. I did something there on purpose. On the top, I factored a cosine out. And the reason why I did is because I know I have a cosine squared on the bottom. And if you have cosine theta over cosine squared, one of the cosines cancels. And so all you're left with is 1 plus sine theta over that single cosine factor that was still in the denominator. So this is what we get when we multiply this expression by this. All right, next one. They want us to take this expression, number 15, take this expression, sine theta plus cosine theta over cosine theta plus cosine theta minus sine theta over sine theta. And what they want us to do is get a common denominator between these. So put these two together with the same denominator. Right now, one of them has cosine, the other one has sine. So what we're going to do is we're going to introduce a 1 next to each of these. I'm going to just get rid of the 15. So I have some room. I'm going to multiply this fraction by sine theta over sine theta. That way I have a sine and a cosine down here. And on this one, I'm going to multiply by a cosine theta and a cosine theta. That's just me trying to attempt to get a common denominator. So sine theta, cosine theta, cosine theta. Now in the numerators, I actually have to distribute that sine through. And here, since I have two terms, I have to distribute the cosine through. And I should get some pretty good things to happen here. Let's see. See, sine times sine is sine squared. So we have sine squared theta. And then sine times cosine is just going to be sine theta times cosine theta. That's all over my common denominator, which is sine theta, cosine theta. Then I have plus. Now when I distribute here and here, I get cosine squared theta. And then this one to this one, I get minus sine theta, cosine theta. Then all over the common denominator is sine theta, cosine theta. So now I can put these together because they have the same denominator. So when I put those together to save myself some time, it's just going to be this plus this all over the common denominator. So I'm really just going to kind of group them together, the plus sign, and then all over that common denominator, which was sine theta, cosine theta. And we get some really good things to happen now. Notice that we have sine squared theta plus cosine squared theta. That's 1. Okay, so that's a very important identity. So I get a 1 there, and then these two cancel. They're gone completely. They're the same thing, but opposite in sign. So I just have a 1 on top. And then in the denominator, I have sine theta, cosine theta. And that's it. That's very nice. Now I could, if I want to, not sure what the book does here, I could split this into two fractions. And this is cosecant theta, and this is secant theta. So you could say that this ugly expression that we started with before I put all this other junk in, this and this together, is just cosecant theta times secant theta. No, they did not do that. They left it as this. Okay, either way. Okay, this one says multiply and simplify, number 17. Multiply and simplify. Sine theta plus cosine theta in parentheses. And then sine theta plus cosine theta again. And then all of that minus 1. Then all of that over sine theta, cosine theta. What a mess. All right, so when we multiply, notice this minus 1 is kind of by itself. So I need to multiply these two together. So I need to do this, 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 right? So when I FOIL that out, I'm going to get sine times sine, which is sine squared, theta. Then sine times cosine, which is, well, sine times cosine. And then my middle term, here and here, is another sine times cosine. And then my last one is cosine times cosine. They're both positive, so I should get cosine squared theta. And then don't forget I have the minus 1 out there. All of this over sine theta, cosine theta. All right, now I see right here I've got sine squared theta. And then here I've got plus cosine squared theta. I know that that's a 1. This and this together is 1. But then I'm subtracting 1. So basically that, and that are all gone. Okay, that's 1 minus 1. And notice here I have sine theta, cosine theta, plus sine theta, cosine theta. That's 2 of them. So I've got 2 sine theta, cosine theta. It was 2 because I'm adding, right? I'm not multiplying those. And then all over sine theta, cosine theta. And look at this. Sine thetas cancel, cosine thetas cancel. All you're left with is the number 2. So this big old ugly expression is just a very complicated way of writing the number 2. All right, number 19. So the instructions on 19 are to factor and simplify. Factor and simplify. So 3 sine squared theta plus 4 sine theta minus 1 over, plus 1, over sine squared theta plus 2 sine theta, and then plus 1. All right, now look, you can't just start canceling these things because we have addition between things. You can't do that. So we look at the numerator, and the numerator looks like a quadratic because it's like, this is almost like x squared, right? This is like x. This is like x squared, that's like x. So this almost looks like this. 3x squared plus 4x plus 1 over x squared plus 2x plus 1. So if you just look at the coefficients, 3 and then something squared plus 4 times that same something and then plus 1, we would get something that looks like that. And we know how to factor this from college algebra, right? This would be like 3x, x, and then 1, and plus, and that should give us the top. The bottom should be like x plus 1 times x plus 1. So I'm trusting you could factor those. Our problem is just like that, except instead of x, we have sine. So this should become 3 sine theta plus 1, and then sine theta plus 1 over sine theta plus 1 times sine theta plus 1. So I'm just replacing all the x's here with sine thetas. And the only thing that happens here that's good is that this factor and this factor cancel. These look like they would cancel, but again, we have addition between them, so we can't do that. So we're just left with 3 sine theta plus 1 over sine theta plus 1. It's kind of like if we canceled here. We'd have 3x plus 1 over x plus 1. Right, we can't cancel the x's or the 1's. So we just leave it like that. We're just going to leave that like this. Okay. All right, that was all of the setup, getting us ready to do these problems on our own without any sort of guidance as to what to do. So I think I'm going to kick my shoes off here. Stretch out for a second. Second. All right, here we go. So on each of these, we want to establish the identity. So let's start with number 23. We want to establish the identity that 1 plus tangent squared of negative theta equals secant squared theta. Let me just double check that that's what it says. All right, so we need to start with one side and turn it into the other side. And we always want to start with the side that looks a little more complicated. So this one over here. When I look at this, I'm already thinking that we have an identity that actually says this, that 1 plus tangent squared theta is equal to secant squared theta. But here we have negative theta, right? Instead, make sure I wrote that down right. Yeah, we have negative theta instead of positive theta. So what we need to do is go back to the even and odd properties. Let's see if we can do this, if I can look this up for you real quick. Where is it? Where the heck are they? Hold on a second. Something ain't right. What are Pythagorean identities? Okay, that's the big identity. So tangent, I divide by cosine, cosine. And then here, cosine secant squared, yeah? Hold the ship. I'm either having a major brain fart or there's a problem here in the book. Here we go. Okay, hang tight. I've got to check this real quick with someone. Okay, I thought I was having a brain fart, and I was. Okay. My goodness, Robert. Okay, so I know this identity is true. Plus, okay, now look at this right here. This is the same as tangent of negative theta, that quantity squared, equals secant, no, sorry, we're not saying it's equal to secant squared theta. We're trying to establish that it's equal to secant squared theta. Where did my rag go? All right, so now I cannot believe I had a brain fart on this. Okay, this right here, we can use the odd property of tangent. We know that tangent of negative theta is equal to negative tangent of theta. All right, that we know from prior knowledge, even in odd properties, so tangent is odd. So if you plug in a negative, it's the same as plugging in a positive, but bringing a negative out. So this right here is equal to negative tangent of theta, but then that quantity squared. All right, so that's equal to that. And when you square this, you square the negative and you square the tangent, because that's really like a -1 multiplied. You're going to get 1 plus tangent squared theta, okay, because that becomes a positive, and the tangent, when you square it, becomes this. And that is secant squared theta, which is this. So that checks out. I'm ashamed of myself right now. Oh well. Hopefully the rest of these go a little better. Geez, that was the first one. It was almost so easy I couldn't get it. All right, let's do this one. 27. So 27, I have tangent of u, cotangent of u, minus cosine squared u equals sine squared u. All right, so now we're going to start with this side, try and turn in this side. And what I'm going to do is I'm going to turn this into sine and cosines. So that's sine u over cosine u times cotangent, which is flipped over. So that's cosine u over sine u. and then minus cosine squared u. Now the sines cancel, the cosines cancel, and I'm just left with a 1 there. 1 minus cosine squared u. And that, again, is a Pythagorean identity. We had, remember, sine squared theta plus cosine squared theta equals 1. And if we bring the cosine over to the other side, so minus cosine squared theta, get rid of it here, you get 1 minus cosine squared theta is equal to sine squared theta. So this is this. Let's see. Oh, that's nice. All right, number 27 is done. All right, number 31. Secant theta plus tangent theta. Secant theta minus tangent theta. Show that this is equal to 1. All right, well, I've got two sets of parentheses. My natural instinct here is to go ahead and just multiply these out. So when we multiply that, we're going to get secant squared theta. That's our first multiplication. And then when we multiply these two, I'm going to get negative secant theta, tangent theta. But when I multiply these two, I'm going to get positive secant theta, tangent theta. And then when I do the outer two, I'm going to get minus tangent squared theta. And that's because I have a positive times a negative, which is negative, and I'm doing tangent times tangent, which is tangent squared. Notice that the middle terms are going to go away, and all you're left with is secant squared theta minus tangent squared theta. Now, if you go back to the Pythagorean identity, the one from earlier, this one right here, that identity, if I take the tangent to the other side, tangent squared to the other side, move it over here, it becomes this, and that's equal to 1, and that's what I have, right? This is that, so this is equal to 1. Check. All right, that was number 31. Now number 35. Sine theta plus cosine theta squared and then plus sine theta minus cosine theta squared. Show that that's equal to 2. Okay, let's start with that left side. If I square this, right, I have to do sine theta plus cosine theta times sine theta plus cosine theta. And then plus, when I square that, that's sine theta minus cosine theta, sine theta minus cosine theta. And I want to see what this turns out to be. So let's do our little FOIL here. So if we do that, you're going to get sine squared theta plus 2 sine theta cosine theta. I'm not showing that middle step, but when you do the middle multiplications, you're going to get the same terms, and you just collect them together, you'll have 2 of them. And then your last one is cosine squared theta. Same thing here. When we do our first one there, we're going to get plus sine squared theta. When we do our middle ones, we're going to get 2 of the same thing, but they're both going to be negative, so it'll be minus 2 sine theta cosine theta. And then when we do our last multiplications, we're going to get plus cosine squared theta. And that's because a negative times a negative is positive. So I didn't show this part and this part. I'm trusting you can get that yourself. But notice that this and this do cancel. They do cancel each other out. And then we have 2 Pythagorean identities. We've got sine squared theta plus cosine squared theta. That's 1. Plus another one of those. So that's 1 plus 1, and that's 2. So that checks. Never going to live that one down. Okay, number 39. we have secant u minus tangent u equals cosine u over 1 plus sine u. All right, so we have some options here. We can start with the left side or the right side. I don't know. I'm going to start with the left and see if I can turn it into the right. So I'm going to rewrite secant u as 1 over cosine u. And I'm going to rewrite tangent as sine u over cosine u. Okay. So we have the same denominator there, right? So we could put these together. So we could do 1 minus sine u over cosine u. That's what this left side is. But I need to make it look like this. So how do we get from there to here? Well, one thing I could do is I could tell myself, well, look, I need to get a 1 plus sine u in the denominator here. So why don't I just come in here and multiply by a 1 plus sine u on the top and a 1 plus sine u on the bottom. That will force us to have a 1 plus sine u on the bottom. And then multiply these out. So I'll take those two terms, multiply them times this across. And since this has two terms, this cosine is going to have to go through like that. But I'm actually going to hold off on the cosine u. And the reason I'm going to hold off on it is because at the end of the day, I want this 1 plus sine u to be by itself. So I'll leave that cosine u just hanging off the end. When I do my FOIL here, 1 times 1, that gives me 1. And then I do this one, I get plus sine u. And I do this one, I get minus sine u. And then the last one, it's a negative times a positive, so I get minus and then sine squared u. And that's all over my denominator, which I said I'm going to hold off on. I'm not going to multiply that out. And notice I get these to cancel. So my numerator is 1 minus sine squared u. My numerator is 1 minus sine squared u, which, because of the Pythagorean identity, is cosine squared u. I know this. So I can replace the top, which is cosine squared u. And the denominator had that cosine u sitting there, and then times 1 plus sine u. And look at this. One of the cosines cancels, and you're left with cosine u over 1 plus sine u, which is this. So that's one way you could have got to it. There may have been another way, but that way works. Okay, how about 41? 3 sine squared theta plus 4 cosine squared theta equals 3 plus cosine squared theta. All right, I think the left side looks more complicated. So I'm going to start with this. And I'm going to recognize I cannot do Pythagorean identity here because these both don't have 3's, or you can say they both don't have 4's. So you can't do that. Man, there's a couple of ways to do this. I see one way that's really actually kind of clever. Like if these were both 3's, we would be in business, because then we could factor a 3 out. So watch this. I'm going to rewrite this like this. So do we agree that if I have 3 cosine squared thetas and I add a cosine squared theta, that would give me 4 of those? That should work, right? Now look, if I just focus my attention right here, these both have a 3, so I can factor out a 3. And then I still have out over here this. And now this is 1. And 3 times 1 is 3, so I get 3 plus cosine squared theta. Oh, wow, that's tricky. That's tricky. Another option, let me just show you another quick option of this one. And this is what I was initially thinking was, I want my answer to have cosine squareds. I've got cosine squareds. I don't like this sine squared being here. So what I can do is I can rewrite sine squared theta as 1 minus cosine squared theta. That's using the Pythagorean identity. Plus 4 cosine squared theta. I'm going to figure out what this is. Distribute my 3 through. I've got 3 minus 3 cosine squared theta plus 4 cosine squared theta. And notice now that I have negative 3 of these and plus 4 of them. When I put them together, I get 1 of them. So I'm going to have 3 and then plus 1 of those cosine squared thetas. So that works also. That's pretty clean. Doesn't require any kind of crazy little arithmetic. All right, 43. 1 minus cosine squared theta over 1 plus sine theta equals sine theta. All right, let's see how much time I've got here on this video. 31, okay, I'm gonna take a little break here in a second. This is more complicated than this. So I'm gonna start here, and the first thing I'm gonna do is I'm gonna get a common denominator. That means I'm gonna rewrite this one as 1 plus sine theta over 1 plus sine theta. Because then when you put that together here, with this one, they both have the same denominator, okay? Now put them together, you get 1 plus sine theta minus cosine squared theta over 1 plus sine theta. I'll go another step. I know that my final answer does not have any cosines in it, so I'm going to get rid of that. I'm going to turn this into a sine. So this is going to be 1 plus sine theta minus, now be careful here with your parentheses. Cosine squared theta is the same as 1 minus sine squared theta. Pythagorean identity. And then this is 1 plus sine theta. Don't cancel these. You can't, okay? There's 3 terms. You can't cancel these. Let's distribute that negative sign, 1 plus sine theta minus 1 plus sine squared theta. That's where we are. All over 1 plus sine theta. So distribute minus and then plus. The 1's cancel. And so what we're left with is sine theta plus sine squared theta over 1 plus sine theta. We're getting close. Notice in the numerator, you can factor a sine out of these. And when you pull a single factor of sine out, what you're left with inside is 1 plus sine theta when you pull a sine from these. And now these cancel, and what are you left with? Now they cancel because there's multiplication here, right? So they cancel and you're left with sine theta, which is what we were trying to show. That's pretty interesting. I might do one more and then take a break. 43, number 49, 1 plus sine theta over 1 minus sine theta equals cosecant theta plus 1 over cosecant theta minus 1. All right, which side to go with here? I think I'm going to go with the right side. There's no guarantee that this is going to be better, but let's try this. If I start with this, I'm going to rewrite this as 1 over sine theta, that's cosecant, plus 1, and then over 1 over sine theta minus 1. All right, in the numerator, I'm going to get a common denominator between these two and denominator, common denominator here. So I need to introduce something. This will be plus, instead of writing 1, I'm going to write sine theta over sine theta. That's 1. And then on the bottom, same thing. Only difference I'm going to have minus here, sine theta over sine theta. And now I can put these two together. So I'll get 1 plus sine theta over the common denominator sine theta over 1 minus sine theta, which is this minus this, over sine theta. And now I have a fraction over a fraction, so I can flip this one reciprocal up here and 1 minus sine theta like that. So I've flipped that, multiplied instead of divided, and the sine thetas cancel. And you're left with 1 plus sine theta over 1 minus sine theta, which is the left-hand side. So I'm done. Having fun yet? Okay, 49. Let's look at 51. 51. 1 minus sine v over cosine v plus cosine v over 1 plus sine v, 1 minus sine v, equals 2 secant v. I think it's obvious that the left side is more complicated than the right side. So let me work with that first. Let's get a common denominator on this. And that means I'm going to need to multiply, get rid of my 51 here. I'm going to multiply the top and bottom here by whatever's here. 1 minus sine v, 1 minus sine v. Okay, and then on here, I'm going to multiply by, and remember, I'm going to try and get this to be 2 secant v. Okay, that's what I'm shooting for. But I multiply top and bottom here by cosine v, cosine v. So I was working with the left side. I'm going to try and turn it into the right side. Now when I multiply these two together, I'm going to do those two like a FOIL. Here, this can be pretty straightforward. Cosine times cosine, that's cosine squared. And so my common denominator is going to be this thing. So let me write my common denominator down. It's 1 minus sine v, and then cosine v. I'm not going to multiply that through. When I do this times this, I get 1, and then I'll trust that you can do the rest. Minus 2 sine v plus sine squared v. So that's what would happen if I multiplied that. Plus, this and this together is cosine squared v. Ooh, Pythagorean identity. Right? Pythagorean identity, that's 1. Yeah, this is it. This right here, this and this together, that's a 1. And I already had a 1 out there. So that means I have a 2. So I have 2, and then minus 2 sine v, that's all that's left up top, over 1 minus sine v times cosine v. Oh, wow. So, we look way off, don't we? However, the numerator has a 2 here and a 2 here. So if I factor that 2 out, I get a 1 minus sine v. And that's very convenient because I had a 1 minus sine v in the denominator. And then I had that cosine v sitting there. And these cancel. I'm left with 2 over cosine v. And if I rewrite that, 2 times 1 over cosine v, this is secant of v. So I get 2 times secant of v, which is this. So I'm there. All right. I'm at 51. Let me put a little mark here where I'm stopping. And I'll pick up at 53 after I take a quick break.